Hello Year 8s, we're just going to work through the Calculating Continental Drift worksheet on Google Earth. So first thing I want you to do is to open up Google Earth. Then from Connect I want you to download the Dynamic Earth version 2.kmz and then you can open that up, and it's going to open up automatically in Google Earth. So it's in temporary places, so what we're going to do is create a folder in My Places, and we're going to title this folder Hazards. Okay, then we're going to drag dynamicearth.kmz into that folder. That's just so that it will be there when we load it up next time. Okay, so what we can do now is just go File, Save My Places, and then it definitely will be there next time. So now we have a series of layers that we can have a look at. So this is different things that are going to be put onto Google Earth to help us to see different things. So we're going to just go through each layer. When it says to toggle the boundary layer, what you do is you see this plate boundary model. You can just click that box. Alright, so there we see all the boundary layers and the boundary names as well. So what I want you to do is to go to the back of the worksheet, or maybe a separate sheet, and to try and label each of the plates. So you can see that this one here would be number 12, the African plate. So you can go through and label each of those. Alright, once you finish with that, you can toggle the seismicity layer, and that's going to show you all the earthquakes. It's going to show you what depth they are by the different color, and it's going to show you what size they are by the different size of the circle. So the ones that are the most destructive are normally closer to the Earth's surface, and they're larger as well. So answer the questions there. What do the different colours signify, etc., etc. I'll let you answer those. We're just going to toggle that off and toggle on volcanoes of the world. So we can leave the plate boundaries on as well. There we have the different volcanoes. You can see that Hawaiian Island volcanoes. Very odd here to have those in the middle, not near a plate boundary. Now that's because it is a hot spot or a mantle plume we saw in the click view video. So you can see that there is lots of volcanoes, not all of them located where the plate boundaries are. But if you have a look at the earthquakes, you'll see that all the earthquakes, or nearly all the earthquakes, happen close to a plate boundary or at a plate boundary. So a bit different there from the earthquakes. Okay, let's turn both of those off and toggle on the seafloor age. Alright, this is one we're going to use most today, and this is going to show us how far the different plates, or how fast the different plates are moving. So what you see here is a plate boundary, and the different colors are different seafloor ages. So the red is 0 to 10 million years, the green is 80 to 90 or 90 to 100, 110 to 120 million years old. So you can see that where there's a plate boundary, that's that has red on either side, that is a constructive plate margin, and the plates are actually moving away from that plate boundary in either direction. So you can have a look at, so obviously the different, if it's a wider red part, then we're going to see a faster movement of the plate, and if it's more narrow like this one here, it's going to be moving a bit more slower. Now I want you to find Australia like this and zoom in until you can see this plate boundary very clearly. We're going to calculate the age, or calculate how fast Australia is moving northward. So it's moving northward and moving upwards in that direction, away from this plate boundary here. So you find this, if you need to, you can reset it. So just click that north and that will realign it so that you'll be facing north. And then what you're going to do is click Tools and click Ruler. We're going to change this to centimeters, well, it's already on centimeters. And then we can choose any part along the plate boundary and drag it to one of the plate boundary borders. So I'm going to drag it to the border here, which is, that would be 0, so 10 million years old, 20 million years old, 30 million years old, 40 million years old. So it's moved 134 million centimeters in 10, 20, 30, 40 million years. So what we're going to do is calculate how far sorry, let me just get that back up. So it's roughly 132 million centimeters in 40 million years. So the calculation that I can do is 102 million centimeters divided by 40 million years. That will give us an average of 3.3 centimeters per year. And that's how you calculate the how far a plate is moving. So one of the good tools of Google Earth is being able to use that ruler, and you can use that for many different uses. This is just one of them. Also shows you the use of layers. Now you can find lots of different layers all on the internet. So feel free to Google that. You can find you can download layers about tsunamis, earthquakes, volcanoes, population statistics, or lots of different types of things. So yeah, one of the many uses of Google Earth.